is really representative of kind of inhale the future, exhale the past.
It's setting the bar real high in GA 2.0 for helicopters.
We knew it was going to be good. We didn't know it was going to be this good.
This is the future. This will do everything that us private pilots want and more.
Hill is an aerospace manufacturing company with one simple mission. We're making flying cool again. Our beautiful HX50 makes you want to fly, and by manufacturing everything in-house, we make it affordable so you're able to fly. Together, we're creating a general aviation renaissance. We call it GA 2.0. For you, it means a breathtakingly beautiful new aircraft, ready for sustainable aviation fuels and connected for the modern world. Our all-new ownership operating system supports every aspect of HX50 ownership, from in-house insurance to comprehensive warranties and power-by-the-hour maintenance to pilot training and active safety management, keeping you and your family safe. Together, we've built the Hill Global Community, a place that provides easy access to the very best that the helicopter lifestyle can offer, globally and amongst new friends. Clearly, the scale of this task is vast. Create an all-new class-leading helicopter. Create a pioneering, affordable turbine engine. Create an all-new digital cockpit. And then create all of the processes and all of the infrastructure needed to manufacture every single part. Then build it, test it, and approve it. Tonight, we'll showcase all of the progress from across the program on how we're delivering on each of those objectives. Producing a next generation turbine engine is a very big deal, but not because it's difficult. It's because it's absolutely crucial to being able to deliver next generation light aircraft at commercially viable prices. Consider this. There's less than £10,000 of expensive raw materials in an engine of this size and type. And the equipment to make these components has never been more readily accessible. And we have it all right here at PC1. Sure, these machines are complex and extremely highly strung, but the design, analysis and testing equipment and the knowledge that we have available today right here at PC1 far exceeds what the guys that did this originally back in the 60s, 70s and 80s had available to them. That's not to downplay the difficulty of the task. This is difficult, this is complex, this will take time. But before we even start, we know that this has been done before. We know how to make this work. Let me take you now through each of the parts of GT50, piece by piece, and I'll show you exactly how we're doing just that. Unlike traditional engines, the GT50 uses a high-speed, high-frequency, high-voltage direct drive starter generator unit. This unit consists of two groups of components: the mechanical assembly, which includes the rotor, the stator and the casing, and then the power management unit, which is all the electronics, hardware and software that control and operate the device. We've now completed the prototyping of the drive shaft. This is the stub shaft that sits on the end of the gas generator and drives the rotor of the starter generator. And then also the stator and windings, so the laminations, the windings, and the wire terminations that come out of the back of it. And with those in hand and the final casing currently on the 5-axis machine, it's time to assemble it and test it. Given that the starter generator runs at 50,000 RPM, it's important that the system is both statically and dynamically balanced to ensure smooth running and avoid harmful vibration. In order to do this, when we designed the rotor, we built additional areas of land on all of the rotating parts that can be subsequently machined away as the system is both statically and dynamically balanced prior to assembly and use on the test rig. With the rotor balanced and the stator electrically tested, the system can be assembled with its casing and connected to its brain, the PMU. In parallel with the development of the flight hardware, we've also been designing and commissioning the specialist test equipment necessary to test and qualify the system, and then building a lab around it. And here it is. This is our fully commissioned high-speed test rig, which is about to start testing the motor and generator functions of both the mechanical and electronic hardware of the starter generator. This system allows us to prove every element of the performance and reliability of the starter gen across a wide range of operating conditions. Over the course of the next 2 weeks, we'll be mounting the first prototype starter gen system on the test rig and running the system throughout its entire performance envelope. And this major milestone marks the first module of the GT50 engine on the test bench and working. Necessarily, much of the time to date on the GT50 program has been spent developing the core elements of turbomachinery. The reason for this is that these are the elements that consume the most technical resources and take the most effort in manufacturing, process development, and infrastructure development. With these elements of the engine now maturing nicely, we've turned our attention to developing some of the ancillary systems that are also required to make the engine function properly. If you now look at the front of the engine and the general state of dressing of the engine, you'll see that there's much more equipment mounted to the front of the engine and around the engine to serve the various systems on board. Let's start by having a look at the lubrication system. Looking at the front of the engine, you can now see that we've added the lubrication system hardware to the accessories module. At the front of the engine, you can see the yellow filter body, the oil pump tucked in behind it, the oil distribution and scavenge lines, and then the oil tank at the bottom of the engine. The filter body at the top contains multiple functions. It acts as the oil filter itself. It has the oil filter impending blockage warning flag, the pressure relief valve, and then also the oil fuel heat exchanger, which cools the returning oil and heats the fuel prior to injection into the engine. When you look across at the oil pump just below the filter body, you can see that we have a 4-chamber gear pump, which provides one pressurized line of oil to distribute the oil to all of the injector nozzles and jets around the engine, and then 3 separate scavenge lines that pulls the returning oil and the returning air oil mist back from various locations within the engine and into the filter body. The oil tank itself is then conveniently located at the front lower side of the engine and contains around 5 litres of oil, which is enough for all reasonable operations. In addition to the lubrication system hardware, we've also now integrated the key sensor elements for the control and instrumentation system. On this image here, you can see the oil pressure sensor, the oil pressure switch, oil temperature gauge, the speed reduction gearbox chip indicator, the auxiliary gearbox chip indicator, and then the rear bearing chip indicator as well, all conveniently located around the engine. In addition to this, we've also got the Hall effect sensors for N2 that are used to pick up the N2 speed, as well as the Hall effect sensors that pick up torque by looking at the distortion of the drivetrain throughout the engine. In addition to this, we've also integrated the engine mounts both at the rear and the front end of the engine to secure GT50 to HX50. GT50 uses a modern annular combustor comprising of roll-formed, superalloy, laser-welded, interlaced rings. We featured the production of these rings and the development of those processes extensively in previous updates. Now, it's time to bring all of that together. Welcome to our precision laser welding facility here at PC1. Over the course of the last few weeks, the guys have been focused primarily on the processes necessary to be able to take the individual rolled rings, assemble them in a welding fixture, and then to create perfect, repeatable, gas-tight welds between each of the layers of the rings that make up the film-cooled combustion sheeting every time. These processes are traditionally extremely labour intensive, so we've been focusing very much on how to jig and fixture these components so that we can subsequently automate them and eliminate the labour content, making the GT50 combustion system as cost effectively as possible. One seemingly innocuous part of the GT50 engine that's crucial to the performance, efficiency, emissions and reliability of the engine is the fuel injection nozzles. Although these components are very small, their internal geometry is extremely intricate, and the conical shape inside that nozzle that's not dissimilar from the internal passages of a funnel are absolutely crucial to delivering the cone angle of spray that we require, the mean and distribution of particle sizes as it atomizes, and the flow rates that we need to guarantee both the minimum and maximum flow through the engine. In order to develop these to the point where we can freeze it for production, we've been doing a series of tests on our laser visualization rig to measure the cone angle from the nozzles, measure the flow rate, and to study the atomization properties of a variety of geometries very close to the target geometry for the GT50 nozzle. For decades, one of the greatest concerns of pilots to owning a turbine engine helicopter has been the risk of an overtemp on startup causing huge amounts of damage. As you know, HX50 comes with a dual FADEC engine control system that simplifies all of that. The startup procedure is simply turn the master battery on, turn the avionics on, the avionics will come to life, and then simply press the start button and the engine will bring the whole system to life. But what actually goes on behind the scenes when you press that button? The engine team and our controls team have been working tirelessly now to develop every element of the control system that runs the fuel management, the starter generator, to bring GT50 to life and to maintain stable combustion and relight if required during the entire operating envelope of HX50. Let's go over and have a look at the Rufus rig, and I'll show you what this button actually does in practice in the GT50 engine. So this is the combustion test rig that you've seen previously that we used to develop the fuel spray nozzles, the ignition, the swirler and the general geometry of the internals of the combustion chamber for a single segment that we then repeat around the annulus of the annular combustor. Since we've completed that work, the rig is now being used to tune the critical internal core functions of the FADEC system that allows us to stably ignite the flame, control the engine as we ramp up to higher loads and then back down to lower loads, and to do automatic reignition if for any reason the flame flames out during operational conditions. So we've built a sort of representation of the FADEC system here to allow us to demonstrate that for you. So essentially what goes on within the FADEC is the moment you press that start button, the first thing the system does is to initialize everything. So it starts by initializing the fuel pump that you can hear there and priming the whole fuel system, so we've got high pressure fuel ready to be atomized through the nozzles. When we then go on to start the ignition sequence, the first thing that will happen is it'll start the starter generator and bring the starter generator up to speed to get sufficient air running through the engine to be able to create the right air-fuel mixture to create the combustion in the first place. Once we've got stable air pressure, then the igniter starts, and then following that we inject the fuel, and following the fuel injection we then move into a governed mode of operation where we can ramp the engine up and down to different load levels to be able to match the power required by the main rotor. So this knob here represents the engine demanding more, the rotor system demanding more load of the engine, so we can ramp up to full power or back it stably back down to low power, and then as you pull the collective up, the engine has to produce more power again. And all the time, we've got stable, efficient combustion going on within the combustion system. And then once we ramp the engine back down and we're ready to shut it down, it can simply cut the fuel, back the air off once the combustion chamber's been ventilated, and stably shut the engine down with all parameters remaining under control at all times. Now let's talk about the second major module of the GT50 engine that's ready for test, the drivetrain module. The drivetrain is responsible for reducing the output of the power turbine from 35,350 RPM down to a more usable 6,000 RPM to directly drive the tail rotor and as the input to the main rotor gearbox. We're currently producing 5 sets of speed reduction gearbox hardware ahead of testing them on our bespoke speed reduction gearbox testing rig. We've currently got conforming examples of all of the gear components copper plated and rough machined out for carburizing prior to be hard machined to final geometry. We're about to start machining the gearbox casings, and we've been working on all of the other shaft components and mounting components and bearings over the course of the last couple of weeks. Once all of that's done, they can be assembled onto our speed reduction gearbox test rig, which will allow us to drive 2 of the gearboxes back to back using an external drive motor and operate the gearboxes throughout their entire operating envelope. This will allow us to verify the performance of the gear drivetrain itself, of the lubrication system, and of the general reliability and performance and efficiency of all elements of the system. And this will in turn enable us to clear these components for flight testing next year. If we take a look inside the speed reduction gearbox test rig, we have the tested gearbox mounted in the correct orientation, and then you'll notice we've got a second gearbox which is mounted back to it and is actually driven backwards. That's purely there to load the tested gearbox, which is driven through the external motor. In between the components, you can see an adjustable torque coupling where we can wind the gearboxes up against each other, the torque measuring equipment, and a whole bunch of instrumentation to measure every single parameter of interest of the gearbox throughout the entire operating range. With the gearbox separated from the engine, we use external lubrication systems where we can tweak and optimize all of the jets, all of the feeds, and all of the scavenge systems to get them set up just right for how they'll sit when they're working on the engine. Most of the componentry that you can see on the top is already made and is waiting in stores, and the major fabrication of the test rig should be with us by the end of this week, ready to be assembled by the end of the year. Let's go down into stores and I'll show you the components waiting to be assembled. Welcome to the PC1 engineering stores. What you can see here is essentially all of the components that I've just shown you in the virtual world, in reality, waiting to be assembled. Everything from stub shafts and couplings, manifold blocks, bearing blocks, major assembly housings, through to the hydraulic connectors, hydraulic hoses, and then the motors, pumps and drives necessary to run the lubrication system for the speed reduction gearbox test rig. We've also got all the seals and all of the sensors and the machine guards necessary to construct this sophisticated piece of test equipment. Over the course of the next couple of weeks, these components will be joined by the major fabrications onto which they can all be mounted. They'll be assembled over the other side of the hall in the mechanical assembly room before being taken downstairs, mated with the first 2 speed reduction gearboxes, and then that'll be the second module of the GT50 engine on the bench and working. Amongst the crown jewels of any helicopter company is the rotor blades and the associated technology. Our highly optimized aerodynamic design is responsible for HX50's high cruise speed, but with high cruise speed in any helicopter comes the risk of unacceptably high vibration. Over the course of the last 9 months or so, we've been working extensively to optimize the dynamic design of HX50's rotor, our cabin suspension system, gearbox mounting system, and the overall structural dynamics of the airframe itself. We've been using modern finite element analysis to optimize the structural stiffness, mass distribution, and general aeroelastic design of each HX50 rotor blade, ensuring that all of the natural modes of vibration are placed as far away from exciting frequencies as we possibly can. In addition to that, we've taken a very bold move to minimize the amount of vibration that can be transmitted down to the fuselage, making HX50 the smoothest 5-seat helicopter in its class. With this crucial work now behind us, we'll be in a position to freeze the dynamic design of the rotor by Christmas, and then in January, we'll start making elements of the rotor blade for elemental testing before making full rotor blades for full scale testing. As the Gen 2 fuselage matures rapidly, we're taking the last few fleeting opportunities to bake in the last of the improvements that we've picked up on various systems around the airframe. During Heli Expo and also at Duxford, some customers noted that the forward skid leg obscured quite a significant proportion of the cabin door opening, limiting the ease with which you can get into and out of the cabin. We've taken the opportunity prior to freezing the second generation fuselage to just shuffle the whole skid mounting point forward slightly, and also to reduce the chord of the skid pan aerofoil profile here, both reducing the drag and also the weight, making a better all-round skid design that looks basically identical to the one that you see here. In addition to that, we've also slightly shrunk the track of the skids in order to make sure that the unit will fit inside a shipping container without having to remove the skids. While we've been doing this work, we've also been finalising the internal structure of the skids to really squeeze every last bit of weight out of the system that we possibly can, in addition to updating the way that we mount the skids back to the fuselage with the dampers necessary to maximise the performance of the isolation of ground resonance instabilities for the aircraft at large. All of these things have gone to plan over the course of the last couple of weeks, and we're expecting to be able to freeze the design of the skids just after Christmas, ready for testing early in the new year. Another area of rapid development over the course of the last couple of months has been the mechanical control runs that connect the cyclic sticks via underfloor control linkages to the flexible control cables that run under the nose wheel and then up the nose pillar onto the roof to connect with the bell cranks and servos on the main rotor gearbox. During this period, we've been able to significantly reduce the weight of the cyclic mechanism while simultaneously improving the control system stiffness, which is crucial for the dynamic characteristics of the flight controls. In addition to that, we've now implemented all of the friction packs so that the aircraft, when it's on the ground, can have friction applied. And then on top of that, we're currently updating the stick head design here to take account of a couple of modifications in how we want to trim the sticks, as well as the latest layout of the buttons and the switch packs and backlighting that go into the head of the stick and present to the pilot. We've also made similar progress with the development of the control linkages for the collective control. The main news here is that we've made a subtle modification to the pivot point underneath the cabin floor, bringing it slightly further aft. This allows us to use a common axis for both the pilot and the co-pilot's flight control without the stick head for the co-pilot blocking his entry and egress into the cabin. This has made the system significantly simpler, significantly lighter, and again stiffer, leading to an improvement in flight dynamics characteristics. We've also implemented a new stick head with new button packs on the collective, as well as adding the friction system, which will be deployed down here at the base of the collective lever. The last of the flight controls to be developed is the fully adjustable pilot and co-pilot pedals. The pedals in HX50 are a little bit more complicated than they are in other light helicopters on account of we have to facilitate for the wheeled version where we need toe brakes. So that's a toe brake system that's also fully adjustable to give the range of accommodation for the different size occupants that we want to within the aircraft. We're currently trading off two versions of the pedal design, one that's fairly traditional and carries the brake cylinders with the moving assembly, and another that uses a reference mechanism to stationary brake cylinders that are buried in the floor. As soon as we've got the trade-off completed on that, we can freeze that, and then essentially all of the mechanisms behind the flight controls can be frozen, and again we're ready to build them and put them on the test rig. It's generally acknowledged that helicopter seats are in fact instruments of torture, and I'm absolutely determined for that not to be the case for HX50. Over the course of the last 6 to 12 months, we've completed extensive comfort trials and integrated all practical customer feedback. In doing this, we've now created improved comfort surfaces and milled these surfaces in several grades of airworthy carbon-laced foam to enable us to carry out the final stages of comfort trials before freezing the crew seat around the existing mechanical design that has now been frozen, passed the structural analysis tests, and has been approved and ready for production by our production engineers. As you've seen previously, we've also completed the isolated energy absorber tests required for the crash cases. And with the final comfort trials completed and the mechanical design matured and released, we'll be able to release the seat for production, prototyping, and then testing early in Q1 in 2025. One of the areas of the airframe that we were cognizant we needed to improve over these early prototypes was the quality of the forming of the large transparent panels that make up the windshield. Welcome to our all-new glazing production facility here at PC1. This facility has been specifically developed to produce vacuum-formed and drape-formed transparent panels for impact and non-impact resistant windows across the platform. In order to produce optically perfect windows for HX50, we've developed a new approach to tooling both for polycarbonate and acrylic, including new ways of fixturing and holding the hot, flexible material down onto the tool during the forming process. Over the course of the next few days, we'll be trialing these methods to demonstrate the capability of the newly developed process. Today marks another important milestone in the development of HX50. We've now frozen the primary flight display design for the digital cockpit, meaning that Eric and his team can now get on with the important business of implementing this software on the target hardware, ready for testing before year end. The design itself has gone through numerous iterations over the course of the last 2.5 years, gradually evolving from piloted flight tests, customer feedback, and a consistent pursuit of perfection in terms of combining the best elements of traditional analog gauges with all of the benefits of modern digital displays. The production version of the PFD is crisper, cleaner, and more refined than ever before. Airspeed is now conveniently positioned at the top of the display with a simple curved arc giving a needle as well as a digital display. Our new and novel altitude indicator brings the best of analog gauges and digital readouts while only using one needle to present your altitude, irrespective of how high you are above sea level. This is combined with a large, easy to read vertical speed indicator and the large power indicator that's always been a primary feature of the Hill digital cockpit. The rotor and engine tachometer are now crisper, clearer, and more easy to read than ever before, with the engine temperature and electrical gauges provided at the bottom of the screen and a homogenized communication and transponder bar. As in previous designs, we've also got the pass-through layer that provides video footage as a background from the camera installed in the nose light in the front of the aircraft. And the colour schemes have all been adjusted to work perfectly with this. We've also provided the toned down night theme that makes the contrast more appropriate for night flying so as not to glare in the low light environments. And then finally, we've also integrated with that the infrared pass-through layer to make flying at night safer than ever before. Welcome to the new avionics laboratory here at PC1. In this facility, Eric and his team will be implementing the production variant of the primary flight display for the DigiCockpit on target hardware and then connecting all of the peripherals through the target hardware with the control interface ready to be fitted onto the aircraft. They'll start with the PFD and then move on to the IPI and the MFD to bring the full system into aircraft ready status. With the DigiCockpit software implemented on the target hardware, then the very next stage is to connect up all of the peripheral devices such as the GPS source, the transponder, the comm radio, the audio panel, and the various other bits and pieces. Get those integrated with the production wiring loom, all of the switches, the hardware, the circuit breakers, and get the whole system working, laid out on this pegboard prior to being transplanted onto the first flying HX50. Well, what a journey it's been. From 3 small development centres in Rugeley, to a cavernous empty unit in Stafford, to a completely vertically integrated helicopter production facility capable of producing essentially every part of HX50 from raw materials, at a price that will stir general aviation back into life. A uniquely extensive capability, and all done in just 9 months. Standing up here on the mezzanine level, you can see the full extent of the end-to-end composites manufacturing facility that we've built here at PC1. Down below me, our trim shop is now operational and producing patterns and molds for the HX50 program. Our gantry mill and associated dust extraction system is now fully operational and already producing patterns, molds and tools. Our large-scale composite curing oven has now been fitted with an upgraded temperature control system and is operational and ready to cure composites. Behind it, you can see the new paint facility that's fully operational and already producing painted components for the HX50 program. The final piece in the production puzzle for advanced aerospace composites is our laminating clean room that will be finished over the next couple of weeks. Let's go and take a look. The new laminating facility sits right next to the trim shop where the patterns and molds are made that we then use to laminate into. The whole layout of the facility is designed to reflect the way that material flows around the facility, with molds and pattern storage over here, materials and goods inwards into the laminating facility just through this door here, which then flow in turn into the kit cutting area. Let's take a look. When the raw composite materials arrive at PC1, they're brought into this temperature and humidity controlled storage area. They're held here in tip-top condition until they're cooled off to go into the kit cutting area, ready to be laminated. As we move to productionize the Gen 2 fuselage for high volume composite production, we've taken this opportunity to invest in our very first CNC kit cutting machine. This replaces the laborious hand templating and trimming of the individual layers of carbon fiber that need to be painstakingly built up and laid really carefully into each mold to make every element of the structure, with an automated process that deploys rolls of pre-preg or carbon fiber onto a table where a CNC cutting knife will then come and nest and individually cut out each of the shapes required to make up every single laminate that goes into every molded part of the structure. This is our first CNC kit cutting machine, and it's going to be used to develop out all of the processes for making highly controlled, high quality aerospace composite structures. This vast space, when it's completed, will be our clean room laminating shop. It's sized as such that we can lay out all of the tools and fixtures necessary to produce the entire HX50 airframe in parallel and have multiple teams of laminators working on these to hit the production rates that we need to. In this environment, the temperature will be controlled, the humidity will be controlled, it will be dust-free and positively pressurized to maintain an absolutely clean environment to produce high-quality composite components every time. In addition to the environmental controls, we've invested in laser ply placement technology, which means that on top of the complex shapes that form HX50's mold tools, we'll be able to project laser guidelines that tell each laminator exactly where to place each of the CNC kit elements into the mold, ensuring that we get the right components with the right fiber orientation in the right place every time. And what's more, this technology allows us to create a step-by-step digital record of every stage of the laminating and manufacturing process, ensuring that each and every structural part is made perfectly every time. Within this environment, all of the laminating will take place, all of the vacuum bagging will take place, and finished sealed molds will be assembled, vacuum bagged, drawn down under vacuum, ready to cross the walkway over there into the oven for final curing. Our precision machine shop is now fully calibrated and fully operational. The new production control system using smart factory technology is currently being set up so we can monitor the operation and throughput of every machine within the machine shop. We've also completed all of the laser alignment of each of the CNC machines, meaning we're back to hitting the tightest possible tolerances. We've also now completed all of the recalibration of our metrology equipment, meaning once again we can produce and measure parts to the highest imaginable tolerances. And in readiness for the deluge of precision components that we'll shortly be making for both the engine and the drivetrain components, we've just completed a further investment cycle, investing in a new mill-turn machining center that will allow us to produce complex multi-axis components from billet to finished component in a single operation. We've also invested in a new EDM machine that will allow us to put fine hole details and all of the cooling hole details into our in-house cast turbine blades. Tonight, we've shown you that the starter generator is being built right now, the test rig's ready to go, and the starter generator testing will commence before the end of the year as planned. Similarly, the avionics PFD user interface has been frozen. The system is being built in the avionics test lab upstairs, and again, testing will start before the end of the year as planned. Early next year, the electrical system, the crash-worthy seat, and also the drivetrain will start testing as planned. All 4 deadlines on schedule, on time. We set ourselves an epic challenge: build the finest 5-seat helicopter ever, which in turn needed the most cost-effective light turbine engine ever. To do this, we've had to vertically integrate an entire aerospace supply chain. Sounds like a tall order, and it is. But our factory will be home in time for Christmas. GT50 will run for the first time by the 28th of June 2025, and HX50 will take to the air for the very first time by the 20th of December 2025. GA 2.0 is coming. 2025 is our year.
Welcome everyone, literally connections from all over the world, from the 5 continents. We want to make sure that everybody's comfortable and ready for the Q&A. For the ones that are just joining for the first time, this is an update that we do regularly, and this one is this number 17. So we've been doing this since the beginning of the development program, that we update the world where we stand. Jason just gave us a superb update. Well, it's very simple. You can put your questions on the chat and we go one by one. We already have a very good queue, and we'll be very glad to answer those questions, and done directly by Jason. So thank you very much, everyone, for joining us tonight. And well, it could be a morning, could be afternoon, anywhere where you are. And we're going to be starting with the first one right away. So take it over, Jamisha. You have the first one right there. It looks like, yeah, there's a audio there.
There we go. All right. Welcome, everybody. And we've got lots of questions here. Thanks again, Jason, for an incredible update. And the first question is from John, and he's asking, with the HeliMove system, how far will it be able to travel with the battery that we have on board? He says he has about 150 yards from his hangar to the gas pumps.
Yeah, that'll be fine. I think the design duty cycle is about 15 to 20 minutes of continuous use before recharging, so you shouldn't have any problems with that. It does depend on the duty, of course, that being on level ground. If you're trying to drag the thing up steeper ground or rougher ground or softer grass, then it'll consume the power a little bit faster.
Okay.
All right, and Brian is asking, as a client, For those of us who have made a down payment, when is the next payment due? Well, you're not alone. There's almost 1,000 clients all over the world. So can you answer this question, Jason? When are clients expecting to be called on the second payment?
Yeah, so we've consistently said there's two criteria that will trigger the next two payments. The first one was the development of the facilities, having the ability to deliver the aircraft, and the second one was first flight under our belt. So when we make first flight towards this time next year, then after that we'll be calling off the first payments in sequence with the projected build timeline. So the first ones, the very front people in the queue, can expect to be needing that around Christmas time next year.
Okay, we'll get our funds ready for that time. That'll be great. Jim's asking a great question.
Christmas present.
Exactly. Do you have a target date for certification yet?
Yeah, for the approval, the type approval for X50, that is within 2025. So, sorry, within 2026. So after first flight, we've given ourselves a year to get the type approval, and the stated timeline from the CAA is notably shorter than that, with it being the experimental regulations rather than full type certification. The full type certification, we've always said, will take about 2 years beyond that.
Gregory is asking a question about the engine. If you had the opportunity to design a clean sheet, a small turbine that you're designing, why not build a recuperative design to maximize BSFC?
That's a really good question.
Yeah.
And it's something that everybody has wanted to do forever, and everybody has tried, right? Fundamentally, the idea of a recuperated engine is that you use the waste heat out of the exhaust and preheat the air that comes out of the compressor, so you can add less fuel to get to your turbine entry temperature. They work much better off design, and you get much better fuel consumption both on design and when you're at part power. So it would be amazing. When the automotive manufacturers were trying to make turbine engines for cars, that's exactly what they did with their huge budgets and huge resources, and none of them could make the heat exchangers work. Some industrial turbines have tried to use them, and these recuperators are actually bigger than the engine itself, and they suffer with all of the usual problems that you'd get with a heat exchanger that has high thermal stresses and high thermal cycles, that they just crack, they're just unreliable. So whether it's a recuperator or a regenerator, nobody has ever made these reliable for the kind of duty that you get in an aircraft. So I really wanted to do this because it makes the whole turbine engine simpler. It means we can have an aluminium compressor rather than this horrible titanium that we have to machine. But I could never satisfy myself we could make a reliable heat exchanger for that particular duty. So we've been stuck with a simple cycle, which is smaller, lighter. It consumes slightly more fuel and a lot more fuel at part power than a recuperated cycle does, but it works and it's reliable, and you couldn't get to that with a recuperated engine. We may in the future play around with that in the background and see if we can do it, you know, as a sponsored PhD project for somebody or something like that, but it's never going to be a mainstream activity because I just don't think you'll get there with the reliability of the recuperators.
Very good answer. Okay, excellent. And Gabriel's asking, how many engineering man hours did you consume for the design of the engine? And how does this compare to your initial estimates?
A lot. And I think it's broadly in line with my expectations, but it's consumed a lot of time. So I wouldn't want to put a number on it. I can't add it up off the top of my head, but it's consumed a lot of time.
Do you have an idea of what was added in terms of percentage from your expectation? What is reality?
I think we've probably spent to date twice as much time on it as I wanted to. So it has taken a little bit longer than in the early days, but a lot of that was because some of the early assumptions about configurations turned out to have challenges that we couldn't overcome, like the early 3-can combustors made life very simple, but you could never get the weight down enough, and that meant you had to redo a whole bunch of the engine, and getting to the life out of some of the components has driven changes and everything in the core of that engine is so interrelated and so on top of each other. So you change one thing, the changes cascade through lots and lots of components. So you end up with a lot of churn that you can't stop until you've got it just right, because you will just leave problems for yourself. So we've ended up having to refine and refine, a bit like the DigiCockpit. We've had to refine and refine and refine until we've got complete confidence that it's right. And we're very, very close to that now.
Oh, weight. I've seen a question about weight. Get ready in a bit. Just down the line, there's a question about weight there. All right, so Dave is asking about seats. With the seat redesign underway and the anchors are all static, what kind of adjustment of the flight controls will be possible, if any, to make it comfortable for the different sizes and shapes of pilots?
Okay, so in terms of the pilots physically being able to fit in and to reach the controls and use the controls, then the aircraft will accommodate everybody from a first centile woman through to a 99th centile man. And off the top of my head, I think that's about 4'11" for a small woman, up to 6'4" for a large man. And in terms of the front seats, we can accommodate somebody much taller than that. I think we can get up to about 6'6", 6'8" before it starts to get uncomfortable. And then to do that, we end up with, I think off the top of my head, it's about 129 millimeters of movement on the seat and about double that on the pedals. Okay, so we've had the mannequins in there, we've tested and tested and tested this, and everybody will fit. The challenge with a helicopter, unlike a car, is that because you've got a cyclic that needs to move forwards and backwards, you can't move the cyclic controls practically towards you. You have to move the seat forwards and the pedals back. So you can't get away with fixed pedals. But we accommodate everybody within the first to 99th centile. So that side of it, we're very, very robust, very confident about. The one area that you certainly couldn't do as a standard fixture is the amount of adjustment that you can build into the comfort surfaces of the seat. So the latest generation seat is designed based on the distilled best practice of ergonomic thinking from about 1910 onwards. We've got exactly the right shape and comfort surfaces that you should have, and we're just tuning the stiffness of the foam at the moment to make the best of it. I've actually sat in the production seat this afternoon on the gantry mill to try that myself, and it is really very comfortable. But if you're a very different shape to a person of normal height and weight, then there's no way that a single unadjustable carbon bucket can fit everybody perfectly. Now I'm 6 foot, and one of the things that we can't get away from is that in a car you'd have an extendable seat pan so that you can bring the seat pan out further if you've got very long legs. Now it's not really practical to do that in a fixed seat, and the seat pan is limited by making sure when the very small person sits in the seat pan doesn't touch the back of their legs, which is a complete red line. You can't do that at all. So there's compromises like that where to make it work for the small person, it compromises something else for the big person, and vice versa. So we've done something that fits everybody to the best extent that it possibly can. And I think if we've got people that are out in extremes, you might have to look at a bespoke pilot seat service for people that want to go the extra mile and have something custom fitted to themselves. But the basic cabin seat will fit everyone from the first to the 99th centile. You'll have full use of the flight controls, and it is genuinely a lovely, comfortable seat.
But Jason, just talk about the seat itself. I have a question about that certification process. So you're talking about bespoke seat. So
Yeah.
it's possible to do a bespoke seat that is still certified?
So you'd have to requalify it. No, you couldn't change anything without requalifying it. So there'd be a cost associated with it. But
it's possible, like a one-to-one
it's
basis?
technically,
Okay,
on a one-to-one basis, it's possible. I'm talking for the very, I'm talking for people that are really
Percentile shape.
Yeah, people that have very
big.
unusual body shapes or are very, very big or very, very small. It'd be that kind of person that might decide that it's worth it. But for most people, I just don't think you're going to need it. These seats are genuinely really comfortable now. So and the adjustment, nobody has the amount of adjustment in a helicopter that we do now. So if you can fly an existing helicopter, you're going to be really comfortable in ours because we've just provided much more.
Okay, very good. And Gerard is asking about the type ratings for the HX50. So can you give us just a little bit more details on what that's going to look like, the pilots that are going to be offering that type training, and what Hill offers with the purchase of an aircraft?
Yeah, so that will evolve with time. So in the very first instance, it's going to be a small number of our company pilots and our test pilots that are providing training to other instructors and examiners and people that then can go off and support the aircraft around the world. The very early serial number customers will be coming to the factory and will either be appending the type rating to their build school or doing that as a separate booking a little bit earlier to get them the opportunity early to come and experience it. But that will be done in the first instance by our staff pilots here at the factory.
Curious, how many staff pilots do you think we would have in the team?
Again, it'll adapt. I haven't given any real thought to that yet, Ruben. I've got my head in engineering, but sufficient to be able to deliver the training syllabus at the rate we need to. I don't think it needs to be a big number.
Mm-hmm. All right, now he's asking, can you talk us through how the owner-operator pilot can verify that GT50 is producing the required power in the field?
So all of your normal power checks on the engine will be done through the digital cockpit. So the DigiCockpit does a power assurance score for you in the background while it's operating. So all of the stuff that you'd normally do for a turbine engine, looking up against the charts, there's just an index built into the DigiCockpit that does that for you automatically.
Okay. And that does that go for maintenance as well? Like for the engineers, typically on a turbine, the engineers will take it out for a power assurance check. That's going to be done in the background, like you said.
Yeah, it's all recorded for every flight, so you have a full download available from the flight data recorder.
Very nice, and that'll be available on the Hill app then. That'll be great. Very nice. Next question is from Jerry, and he says, how many engine hours will be logged on a single HX50 before the production models?
I'm hoping to be able to, the HX50, I think we can realistically rattle hours up at somewhere between 500 to 1,000 hours a year on the flying prototypes. So the minimum would be 1,000, but I'd hope to get past that before we start production.
And maybe just expand that thought as well. How many engines are you going to have running on a test bench, and how many hours are they going to do on a test bench?
So there's a difference between the testing that's required for certification. So certification testing tends to require very extreme cases and envelope limiting cases to prove that you don't break the thing, and then the endurance tests will often run in parallel with early production. They'll lead early production, but they'll run in parallel with early production because they physically take so long to do. So once we've done the early flight testing program and we've got the measured loads, we've got the measured operating conditions from across the operating range, for us it's then back to the lab tests, back to the bench tests, and run multiple engines, multiple drivetrains, and do multiple structural tests to carry out the life extension work. So when the aircraft enters service, it will have a pared back life, and then we'll gradually extend that as we increase out the testing on the bench. It's the same process that everybody else has to use.
Okay.
All right, next question is about taking delivery of the helicopter. A couple of options are possible. So Ward is asking, is there any additional cost when picking up a ship and sending it to the US? I know about freight, how about tax, etc. How about if I fly it out of the country? So can you go over the options of how the helicopter is delivered and the option of flying out and shipping? How does that work?
Yeah, so all helicopters that Hill provides are delivered ex-works here at the factory, and then it's the owner's responsibility to ship those or take them to wherever they're going. As with other manufacturers, there will be some pilot requirements for being able to fly an aircraft directly away from the factory. And for people that want to ship them, when you ship them into your own territory, then you're responsible for your own import duties and what have you. We'll help with the handling and the logistics of it, obviously. We'll make that as seamless as possible, but the shipping is entirely, the exporting of it is entirely the responsibility of the owners.
Okay, and
By the
just
way,
expand on that.
we should probably, we should add about what we're having some quotes at the moment from shipping companies. You can share that, Misha, as well, so people have an idea how much is
exactly.
What is the current cost?
Yeah, exactly.
That,
So
Misha.
we've been working with a shipping company that ships helicopters globally, a lot of them every year, and that's one of the top shipping companies for helicopters right now. And we shipped at the beginning of this year a couple of helicopters over to HAI in Anaheim, California, and it was about $8,000 or so per container to get it to Anaheim, and it took about 5 weeks to get there. So that's just indicative timing and pricing right now. So obviously people are located all over the world, but that gives a pretty good ballpark depending on where you're going to be shipping, if it's to South America, Australia, or different parts of the world. So somewhere in the ballpark between 3 and 6 weeks should get you pretty much anywhere in the world. And like I say, the cost for each of those containers was around $8,000. And so we're going to be able to connect you with shipping companies as well that'll be able to offer sort of a white glove door-to-door service that's going to make your life a lot easier as well. So, and Jason, I just wanted to ask a follow-up question on that, because I know you had quickly mentioned this on the last AMA, and we had quite a few people ask some questions about it. I know it's way too early to give details at this point, but can you expand just a little bit on what the flight requirements would be for, like, the pilot requirements for flying away from the factory? Because quite a few people asked that right after the last AMA. So I know you won't be able to give exact details, but maybe a little bit of comprehensive idea on that.
To be quite honest, I can't answer that one off the top of my head. I haven't thought about what they are. If you give me until the next AMA, or I'll give you a proper reply. In fact, I'll give you a proper reply in a couple of days' time. You can share that with everybody. It's not something I've considered. It's just something I'm aware we need to do. Otherwise, we'll be creating obvious problems for ourselves.
Exactly. Yeah. And the answer I've been telling people, which obviously this will have to get detailed specifically, but it's, a pilot has to have sufficient experience to be able to safely fly the aircraft throughout different weather and terrain and so forth, but also particularly because it's in the UK, to be able to handle a busy radio, because there's a lot of frequencies, a lot of different control zones and so forth flying through that area. So to be able to handle busy airspace would definitely be one of those things as well.
Yeah, and again,
Okay.
there are things we can support with that side of it, Misha. We've got lots of friendly pilots in the community that would be happy to ride shotgun, and so we can help with that side of it. And the other thing I'd say is there are some precedents set by other manufacturers as to what sufficient is. So we'll look at that and we'll make sure that it's fair. But the last thing we want is to create problems for ourselves with a new aircraft entering in service.
Exactly. That makes sense. Great. Next question is from Clint, and it says, "Hi, Jason. Grateful for all you do, and well done on another great AMA. If one of the wheels of the helicopter jams or gets stuck during the retraction, where a belly landing would be difficult, will there be a manual crank lever or something to push the wheels down in case of gravity not being enough?"
Yeah, there's 3 ways to get the wheels down. So obviously the gravity can assist with it, but if the hydraulic system fails for any reason, then there's a secondary blowdown system, a nitrogen-based secondary blowdown system. So there's two actuation systems that will get the wheels down and get them locked for you. And then of course the structure is being designed so that you can land reasonably stably on the belly if you need to as well.
Yeah.
All right, and before the next question, it's from Peter Wilson. And let's give a big shout out to Peter and Andre, because they have recently completed a round the world trip. So congratulations, friends, again. And it's worthwhile mentioning that. Amazing achievement. They have done a new route, and it was an incredible trip that everybody was really following. It was great to see you guys made it very safely. So Peter is asking a question in that context. He has a preamble to the question. The R66, which just flew around the world, had a Garmin 750 and 500 with a Bluetooth and we linked the two iPads with the Garmin Pilot software. I could prepare the flight plan, drop it into the ship systems during startup, and Andre could get his iPad updated. And at any time of the flight, we could make changes on my screen, on any screen, sorry, that would ripple through to the others or not as decided. This meant we could set up changes on one iPad separately while looking at different views of the existing route on the other one while flying on autopilot with different view again. An ADSB overlayer everywhere. Very safe, convenient CRM, and information rich. Question: will we really only be flying the HS50 with one iPad, or can we link more for redundancy and CRM as above? And where would the second one get situated?
Okay.
Right.
Thanks for the question, Peter. It's a good one. There's a key difference here that you have to understand between our system and the system in the 66. Our system doesn't have an onboard mapping system. We use the iPad for that. Okay, so we have a GPS source. So the aircraft knows where it is, but there isn't a mapping system. So what you're doing with the iPad in the current way of working is you're creating a flight plan using all the non-certified mapping layers on the electronic flight book apps. That gives you a series of waypoints that you're then squirting over to the certified navigator, and then the autopilot links to the certified navigator. Our system works slightly differently in that our autopilot controller takes the waypoints directly from the app using the GPS source on board, so it knows where it is and it knows where it's got to go to, and then the flight control computer will act on that directly. So we can, in theory, send from any iPad you want. You could link different iPads to the system and squirt that information over to the flight control computer, or you could have multiple users on one of the electronic flight book app accounts, and you could pull up a different flight plan while you're flying and then just update that to the system. So all our system cares about is essentially a list coming across from one of the flight book apps of the waypoints. It'll read that in, acknowledge it on the primary flight display, so you can see you've got the same route on the system that you've got on the flight book app, and then it will fly that. So in practice, there are a number of ways that you could link as many iPads as you wanted to the system. You'd have one locked in and linked into the system and running off it, but you could be sharing a route with that one and then pulling it across, or just opening a new route from a shared cloud account, whichever way you want to do it. And you can have as many iPads on board as you want to. We've got plenty of USB power. And in terms of there's obviously practical limits to how many iPads, particularly big ones, we can have decorated around the cockpit without it becoming a jumble sale. So we've provided enough room to put a massive one in the middle, and that's the one that both pilots should be using to navigate and to share information. But there's nothing stopping you having a window mounted one for the secondary, or we could look at providing some additional mounts. But if you put anything else in that cockpit now, it's going to start to detract from your outside view. So I'd suggest that for sort of crew resource management, when you're doing flight planning while you're on flight, it might be that you pull out a stowed iPad, do your flight planning, and then share it to the iPad that's linked to the system, and then do it that way. That would probably be the most logical way to do it at the moment.
Very good. Excellent. And Brian's asking, hello from New York. Let me first tell you, great job with all the Hill enterprises. The only thing that is stopping me from becoming an owner right now is some financing. Is Hill going to offer some type of financing option in the future?
Absolutely, we will, yes. I think that's a key enabler for increasing the uptake of the product. We'll absolutely be offering that, but that's not something that will follow until after we're in production. So we're actively working on it at the moment. It's one of the areas that we know is important for our future. So yes, you can expect that, but not until after we're in production.
Good.
All right, next would be two questions. I'll be asking the first one, and then I'll ask the second one to you, Jason. So Paco from Mexico is asking, good morning. One of our companies will be interested in exclusively distributing the helicopter in Mexico. So Helicopters has a different approach to the market. All the sales are done directly by HALE worldwide. So we don't have any agents, resellers, or distributors anywhere. This is assuring that all the information and the education process that is you see that is important throughout this development program is exclusively done by HALE Helicopters. So we really appreciate your interest. There is an opportunity if you want to still order aircrafts under special conditions, because before production starts, there is a discount that's available. You can buy as many positions as you want, but distributing it and having a formal agreement, that is not available anywhere in the world. So Gene is asking, if we elect to go the skid version, what will be included for the ground handling?
Conventional ground handling wheels come as standard, so the over-center ground handling wheels. That's the main way to deal with it on the ground. We're looking at the option of doing a HeliMove version of that as well, but we haven't done that yet, so we'll have to look at the practicalities of that.
Okay. And Gene's asking another question. Just before that, it'd be worth mentioning as well that we also have a very quickly growing network of service centers interest right now. And service centers is something we're going to be establishing about 6 months or so before production begins. But right now we're taking informal applications, which means people are showing their interest, saying that they'd like to become service centers for HIL. And we're taking note of those, and we're going to be following up with those as we get a little bit closer to production time, but making sure that we have a very large and robust network worldwide for servicing the helicopter wherever you're situated and located. So for Paco in Mexico, if you do have interest in a service center, that would be definitely something that we would take a look at as well. And that's going to be something that we're going to be establishing, like I say, when we have all the data of where all the aircrafts are located. So we're going to be establishing those in the best locations for the customers that we have. So Gene's asking a question about the door latches. Are the door latches going to change from the current setup that you have? I think you mentioned that on the last AMA, but
yeah,
you want to cover that again?
It's a complete root and branch rethink. So we'll stick with the appearance of the door handles on the outside. The feel of those will change a little bit. The spring stiffness and the damping in there isn't quite right at the moment. And the doors are moving to a 3-point locking mechanism as opposed to a single point that we've got in those ones. So I had to choose what we put in this update because there's an awful lot of stuff going on. There's a whole package of work going on doors and locks at the moment. There's a whole bunch of stuff going on the airframe that I haven't reported yet. I'll pick all of that up in the next update, and we'll probably be able to show you some hardware by then as well.
Fantastic. So Martin, next question is, if in the UK an owner, say 3 years later, wants to syndicate the heli, is this possible? As the new part owners clearly won't have been part of the build. Also, what happens if the heli is sold on as the new owner also won't have been part of the build?
Yeah, I don't believe that's a problem at all, no. So I've had that discussion directly with the CAA here because there's all sorts of practical things that can happen for completely legitimate reasons that there isn't provision for in some of the regulations at the moment, and they've been very practical about that to date. So I don't imagine that's going to be a problem. I think there's lots of examples of where that's been done before in practice, so I don't think that'll be a problem for you at all. But again, we'll provide some guidance on that as soon as we've got formal agreement from the CAA and then the other authorities around the world.
Excellent. And Sean is asking, you've mentioned that there's going to be some changes to the controls, the cyclic and collective.
Sorry, Misha, can I just add one other thing to that last question? The main reason that you might think that there are some restrictions to what you can do with amateur built aircraft, it's to prevent people from circumventing the proper regulation and control. And because, so for example, you wouldn't want somebody buying a kit of aircraft, assembling it for themselves and then selling it as a pre-built aircraft. And a lot of the regulations have been set up to prevent that. Because we've got a formal build school, it's an aircraft that's designed to the full Part 27 regulations, where it'll be done under a design approval and a production approval. That whole landscape is different. And so I think it makes the whole situation a lot simpler for people that have done it the way that we've done it. This isn't, you can't really compare this to a kit build aircraft at all.
Right, exactly. Okay. Excellent. And Sean's asking about the control head. So for the Cyclic and the Collective, you mentioned that there's going to be some changes of the buttons and controls. Are you able to make a mention of what those changes actually are?
Yeah, the only reason I didn't include that tonight is because we haven't got any fancy visuals of them done yet, and it's much easier to articulate it with that. So we've done a lot of work on the autopilot. And we've done a lot of work on the DigiCockpit, and those things have pushed some changes back to the stick heads as to better ways of using the buttons. So for example, we've still got a plus and minus frequency button on the original version of the stick head. That makes no sense. That dates back to the old Bendix King radios where you could store maybe 5 or 10 frequencies. Well, in a DigiCockpit world where you've got a nearest list or an en route frequencies list or a favorites list, you're much better to have a shortcut key to a list function that will bring up the lists on the DigiCockpit that you can then tap and things like that. So the way we've evolved the buttons is to make them much more usable in the context of the DigiCockpit. We've also changed the way the buttons work with respect to the latest versions of the autopilot, so that the autopilot, what would traditionally be the force trim release button, is now in the trigger position on both the Cyclic and the Collectives, because we've got a trigger on both Cyclic and Collective. That will be much more intuitive than having one on the Collective and one up here. And the autopilot system works differently to what you might be used to if you've used the HeliSAS system, in that the basic stability functions are completely invisible to the pilot. So they just operate in the background, they don't move the flight controls. So your autopilot on button will actually push you up through different layers of stability control. So again, you're probably better off waiting and letting me illustrate that with the stick heads in front of us and some proper visuals of how the DigiCockpit works. But it's really, really intuitive. It's really simple to use, and it just brings the stick heads up to date for 2024 with an active flight control system that's been designed in from the word go. And the reason you want the triggers, of course, is all the flight controls have got haptic feedback on them. So the Collective, for example, will stay exactly where you put it. It won't creep down. You won't need to put friction on to hold it there. It'll stay there because there's an actuator on it. And you need a way of communicating with that actuator as to what you want it to do. And the same with the Cyclic. You've got haptic controls on the Cyclic, so you have to be able to intuitively work with those. So it all sounds like a little bit of technical mumbo jumbo at the moment. If you let me demonstrate that with the stick heads and the graphics, we'll pick that up in the one of the next AMAs. But I guarantee you'll love it. It's a really, really nice system.
All right, I must say that to today's questions, the level of novelty has been, I think, above average. Incredible. Really nice session today. A lot of new questions. Great to have all the questions from everybody, and we motivate the ones that have not asked questions yet. It's your time to put it in, because you're going to be closing in about half an hour. So if you want to ask questions, just put them in. Make sure that we could be able to answer those. And Keith is asking about the lubrication of the range of motion in the Cyclic and Collective. What does it ensure you have a smooth experience? What type of lubrication you have there?
It's less about the lubrication than it is about the flexible flight control cables that I've shown you. If you go and see those cables, those are sealed for life. They have a 20,000 hour on condition life, and they've got the smoothest action in tension and compression in and out that you've ever seen. It's totally different to what you'd be used to with conventional mechanical control runs. And the benefit of that is essentially we've only got some simple flight control mechanism under the floor to get the Cyclic into the end effectors for the flexible control. So you've got far less play and far less bearings to go through. And then we've got your usual sort of maintenance-free Teflon lined or similar plain bearings on the rod ends and things in the flight control system. So very conventional to what you would have seen before in the underfloor stuff, but the big difference is those flexible control cables that go right up to the hydraulic servos on the main rotor gearbox.
So no verification of the cables, right?
No,
There's no
no.
need to maintain those.
No, they just get an inspection on 100-hour and multiples of 100 hours. So, but it's literally just it's a simple full and free check to make sure there's no friction, no hard spots, flat spots, and an inspection of the cable runs. The cable runs are easy to see when you take the cowls off the top and the cover off the nose. You can see the whole cable run. So it really simplifies it.
Yeah, I've flown several helicopters with them, and it's fantastic. It's a great system. So, Ernesto was asking, any innovation on bird strike protection other than polycarbonate windows, as well as another question, any chance to run a predictive maintenance program?
So yes and yes. So in terms of bird strike protection, we've obviously got the polycarbonate windows in the front to protect from frontal impact. The beak on the bridge of the nose of the helicopter is also designed for impact, and that's really designed to deflect birds and drones or anything else away from the sensitive swash plate and pitch rod linkages. So one of the other benefits beyond aerodynamics of cowling the rotor system in is that a lot of bird strike fatal accidents historically have involved damage to the pitch links and pitch control mechanism up on exposed helicopter rotor pylons. So by having that all lined with bird strike resistant composite panels, it gives us another degree of protection up there. And then obviously with the enclosed ducted tail rotor, then your probability of being able to knock a tail rotor gearbox off is reduced to almost zero, and less of the weight back there as a proportion is in the tail rotor assembly itself. So if you did have some damage from a bird getting in there, then you wouldn't have the kind of problems that have traditionally been associated with a tail rotor bird strike, where if you knock the gearbox off, you're totally out of CG and you crash because you're out of CG. We're far more resilient to that. So you've got those three primary factors really that contribute to making it much more resistant.
Good. And the follow-up question was about
question.
the predictive maintenance.
Predictive
program.
maintenance, yes, of course. So obviously one of the things that we do within the aircraft is we track everything, right? So all of the parameters, the way the aircraft's being used, all come from the DigiCockpit into the app and then up to the cloud. And so we can trend monitor all of the parameters that would give you an indication that something's not happy, or something's not being used correctly, or it's experiencing things that it shouldn't, and then essentially step in before that becomes a real maintenance issue. So you used the example earlier of looking at your measured gas temperature against torque readings and things like that. Well, we can see that. We can see that all the time. So we can step in and deal with things like that. Oil temperatures or general temperatures and pressures not being where they should, that will get flagged immediately. The only thing that we don't have a plan to do at the moment is to pepper the thing with accelerometers and start looking for vibrations and things, because you just have so many problems with the reliability of those sensors that the machine would constantly be in the shop waiting for new sensors, which we don't want to go down that route. So there's a practical limit to where you'd want to be. And for a lot of these machines that are private, they're not going to get the utilization to warrant that kind of thing. But your general trend monitoring and health monitoring, we can do all that through the DigiCockpit, through the app, and then back up to the cloud.
Okay. And I just had a quick follow-up question about going back to bird strike, but actually about wire strike. I know it had been mentioned at one point or talked about it. Somebody had a question on it. Is there any movement of trying to put some sort of wire strike protection on the front end of the gearbox, so underneath that cowling, to protect for wire strikes?
In all honesty, we haven't done anything about that yet. The structure is strong enough to carry that kind of a system, but we've done nothing to actually implement it yet, Misha. So we'll come back and visit that as part of the suite of options that we're picking up later on in the program.
Okay.
All right, Carl is asking next question. Hi, Carl. Good to have you, every single one. And Carl is asking about how are you doing on weight goals? What is the current dry weight and what is the goal? The ship with its comfy seats Large pillars looks heavy.
That's a very good point.
That's Carl. That's Carl. Yeah.
We're doing okay at the moment, but of course there's still a lot of little details that have got to be added into the assembly that will add weight. So at the moment we're pretty much where we need to be in terms of all of the big mechanical assemblies. So the rotor blades themselves we can bring in underweight, but you'd then push those back up to the weight target to get the most inertia that you can. The rotor hub, the gearboxes, they're all about where they need to be as well, so we're pretty happy with that. The fuselage is a little heavy at the moment, but we've still got a lot of optimization to do on that before we release the final Gen 2 pattern, so that will get back to where it needs to be. The big comfy seats are on target actually. They've got a 7 kilo weight target and they're about 7 kilos. So those are coming in okay at the moment. So we're about where we should be. So I'm not worried about weight yet, and I do have a little bit in my back pocket if I need it.
Secret spots.
Yeah, always have an out, right? That's a helicopter pilot thing. Always have an out. So yeah, we've got some weight margin if we need it. At the moment, we're doing okay.
We can relax, Carl, right? No worries.
Yeah,
there.
Carl, don't fret, Carl. It will get off the ground with you in it.
Very good. And Giuliano's asking a question here. So for those of us who are flying in colder regions, such as Canada, do you envisage needing any sort of an engine block heater like the likes of a Tanis heater?
We probably will need something like that. Again, we haven't done a lot about that yet. In terms of the very cold climates, it's more the functionality of the systems down at those very cold temperatures that we're focused on at the moment. So there's no problems with the materials, with the rubber seals and various other things that we use, that the electronics are capable down to those sorts of temperatures and all this sort of stuff. So we're focused on those primary things at the moment. And then if we need add-ons to support particular systems in extreme climates, then we'll pick that up later. Cold weather testing is part of the flight testing program, so any of those things will be shaken out there.
Okay, will it be possible to select units from some of the displays, for example, inches to Pascal instead in mile per hour for knots?
It's down in the IPI section for most units, so that you can convert those to what's customary in your part of the world. It's a very easy thing for us to implement and change. There's certain areas where it's a bit easier to access. So the fuel gauge, for example, you can tap that and that'll go from units of weight to units of volume to a percentage, depending on what you want to do. So when I showed the scheme earlier, it just showed it as a percentage, as you would in a car, but it can also show it in a volume, in liters or US gallons per hour, and it can also show it in a weight, depending on what's most convenient for you. And then whether you're using metric or imperial or some other random unit system, we can accommodate that as well.
Can that be linked to my profile as a pilot? Can that be customized and then linked to my profile?
It will be, yeah. Your settings will be linked to your login profile.
Okay.
Excellent. And Jim's asking, and I can answer this one, will you produce a video of this session for us to share with other staff? The answer is yes. Usually within a few hours, definitely by the next day, we have this AMA session put together so that you can share that. And so we'll be sending that out on the various different platforms for you to be able to have. We'll definitely be putting it on the Hill app as well. And then Justin and Becca are asking, with the current space that you have in PC1, how many HX50s do you plan on finishing each per week for the ramp up and the first few builds, having refined the process?
So PC1 won't operate in isolation in terms of production, as I think I mentioned in a previous AMA. We'll start fitting out PC2, which will be a much bigger facility once we're airborne and we've got a clear knowledge of what's left to do, and we've built all of the components. So if we were to just try and build helicopters here, I think we'd be limited to about 100 a year. So this will cover development aircraft, it'll cover 0 series, but PC1 will end up most likely either being just a machining center or just a composite center, and PC2 will pick up the rest of it.
Can you share any details of what makes the blade mounting lead to the class of leading ride?
That's what I'll tell you is I'll tell you what we've looked at. So we've looked at all of the ways that you can isolate vibration practically, sort of nodal beams and inertial dampers and active systems and all the rest of it. And there's one method that stands out above all else as the most practical way of getting the ride quality to where you need it to be without over complicating the aircraft. And I would just ask that you give me until let's say January or February time, something like that, to finalize the details, and I'll tell you exactly what we're doing. But I want to get the last few details ironed out with that first. But it's a really obvious fix. And it will make a huge difference to the aircraft, but I'm not prepared to declare it yet until we've finished it.
Very good.
Secrets, right?
Now you're killing us, because we're gonna have a million questions of people asking us what it is. But that's great. It's exciting to have things to be able to share at future times as well.
All I'll say, we've made this helicopter a lot better by doing what we've done. You'll love it.
It's gonna be incredibly smooth. It's gonna be wonderful. I look forward to that. Jacob's asking how sales are going. Sales are going very good, very strong, like normal. And every time major milestones happen, we always have spikes in those sales. But in general, sales have been very strong, which is nice. And then the next question is, great presentation. First flight test, and when are you expecting to be proven? So I'm not sure if I fully understand the question, but.
So first flight's declared as the 20th of December 2025. And then we'll be going through an extensive flight test program. So the engineering flight test program will, assuming it goes to plan, will happen relatively quickly over the course of the early part of 2026. And then there'll be an extended continuing program of flight testing to support the approvals in various countries, and then on to the full certification thereafter. We'll also, in parallel with that, be doing our extended shakedown testing to just build hours and experience on some of the other prototype aircraft.
What SOI are you at with EASA for the FADEC? What is a SOI, Jason? I don't know what SOI is.
Yeah, it's just a readiness level. We're not dealing with the EASA directly at the moment on that. We're dealing with the UK CAA. And so we're predominantly getting the functional readiness of that to where we want it to be first.
Okay. And Charles is asking, how does the battery for the HeliMove recharge? Will there be option to allow either a manual movement by ground personnel and or a way for them to drive HeliMove themselves?
So to drive HeliMove, you can drive it from inside the helicopter, so you can drive it from the IPI. When it's off, it's disconnected, so you can move the helicopter as if it was a normal wheeled helicopter. And I think we may also provide an ability for a ground crew to have a login to the app as well, so that you could drive a specific aircraft from the app. You'd need a user account anyway.
And how does the battery recharge?
The battery's recharged when the aircraft's operating. So once you're in the air, the starter gen will charge the battery, and the whole electrical system does have a ground power port. So you can trickle charge from your usual domestic sockets wherever they're available.
Did you consider putting a brake on the collective instead of a friction? I had this on my MD Explorer, and it was a lot more practical than friction.
So I'm not sure I understand the question. Do you mean a mechanical lock to lock the control down, or do you mean a magnetic brake as part of an active flight control system? If it's a magnetic brake as part of a flight control system, I totally agree with you, but they're big and complicated and heavy, and our system will work better for our application. If it's a down lock, a mechanical down lock, we have reviewed that really carefully. But we felt that a friction system is going to be more intuitive for pilots in this particular class of helicopters. So the friction will never ever be used to any extent when the aircraft's in flight. It'll always be the flight control and haptic actuators that control the position of the flight controls. So it'll give you that exact position hold that you'd get from the magnetic brake. It'll feel exactly the same.
Okay. Excellent. And the next question is, any plans for an IPO?
An IPO? Yeah. Nothing at the moment.
Okay.
That's a good answer. Nothing at the moment. That's it. And the next one, probably related to that, is how are the cash flows in company finances? That's probably why you're not looking for an IPO at the moment.
Yeah, no, we're in an amazing position, really. It never ceases to amaze me. So we've got a very, very long cash runway in front of us. We're in a fantastic cash position. The burn rate's under control. We still maintain a very, very small team here. So I think the thing that people don't realize is the very small number of people that are involved directly in engineering this helicopter compared to what you would expect in a bigger company. So we've been able to keep the cost of the development program under control. And of course, because we're developing a product that people want, sales have remained strong all the way through the program. So we still have a regular income that offsets that burn rate quite nicely. So we're in an amazing position. And yeah, and the other key part to the puzzle as well is the terms of our contract, which is these aircraft are all paid for up front. So you pay your deposit, and then you pay your 12-month before delivery payment and your 3-month before delivery payment. So we have positive cash flow all the way through the process.
I think that people are really still amazed on how, if you look back, what has been achieved, the number of people, as you stated, it's absolutely incredible, unique. Everything that has been achieved with the number of people has to be an absolutely unique team. So that's something special about Hill that some people don't get it yet. And they look at the project, they think that cash is being burned by the hundreds of millions, but that's the uniqueness of the Hill program.
Yeah, and it's just not, and we've been very careful and very responsible in how we've taken on PC-1, for example. I mean, we didn't buy this unit. This is a rented unit. A lot of the equipment that we have is asset financed over a period of time so that it earns its keep as it goes. I'm still running this like a little engineering company and keeping a very tight grip on what we spend to get this done, because you can't survive this process unless you do that. And I think we're starting to see lots of examples now around the industry with newcomers in a slightly different sector where they've had too much money up front and they've spent it like it's going out of fashion, and you can't do that. You've got to spend every penny wisely and only do what you need to do.
It's a tight ship that will assure us to go to good port.
Yeah.
Exactly. Very good. And Joey is asking, he says, Jason, what keeps you up at night? And what are the biggest issues to date? And what are the upcoming issues that you see being a roadblock?
It's a very good question, and it's still the same thing. The only thing that really frustrates me and will keep my mind churning at night is things related to people and personnel, right? You can't run and develop a business like this without an incredible group of people. We operate in a distressed labor market. And you need to keep your people motivated. You need to keep your people happy. You need to keep all the children playing nicely together, and all of these sorts of things. And those things are actually more difficult than doing any of the engineering. I think you get so used to dealing with the engineering challenges that it's like a soldier in a war zone, right? It's just another bullet. Yeah, you're not sensitive to it anymore. And so we just work the problems one by one. And when you get to the stage that we've got to now, you've got sufficient confidence in your capability, in your team, in the product to know that you've just got to do the work. You've just got to finish the work and it will be fine. So I honestly don't worry about any of the technical things. I've got no doubt that we'll complete what we're doing here, we'll make it work, and it'll deliver everything that I say it will. The things that wind me up are generally related to the business of engineering and operating with a group of people that all have their own needs and challenges.
Fantastic. So next question, I'm just going to give a little hint. I have to, because it's a passion of ours and the sales area, but then you can add on what are all your thoughts there, Jason. So would the price of the HX50 be affordable? Well, actually, it is extremely affordable. And right now you can still order the aircraft with a special discount. Is that, I think right now, Misha, it's 564, right? 564,000 pounds. So it's unbeatable. You can't find the turbine helicopter at this price. It's impossible. So regarding affordability, just you want to add anything on that, Jason?
Yeah. Somebody told me a very long time ago, right, that I can afford to buy a £500,000 helicopter, but I can't afford to lose £500,000. And it was that statement really that distilled in my mind what the operating philosophy for HX50 needed to be, which was this long service life, which a private pilot's never going to fly off, right? So 5,000 hours until you need an overhaul. And at 50 hours a year, which is what the long-term utilization of a private helicopter is going to end up being if it's kept privately by the owner. It's 100 years of flying, right? So you're never going to have a situation where you need to advertise your used helicopter as good times remaining, because it's always got loads of good time, right? It's got a long life. And then the on-condition thing is really important, because it means you don't get this horrible linear depreciation of the machine to virtually nothing. That means your £500,000 gets dissolved to virtually nothing. So the affordability for me is making sure that the asset, the helicopter, holds its value. So for that, we've designed a machine that will hold its value, which then means we can finance it. And then the other responsibility that we have is to control all of the other direct operating costs. So controlling the cost of insurance, controlling the cost of maintenance, so that your overall cost of owning and operating the helicopter is affordable. And there is nothing comes close to HX50. If you fly that machine anything from 50 to 200 hours a year, which is the bookends for private pilots, nothing will come close to the operating costs. Because it doesn't depreciate in the way that other machines do, then it becomes much easier to finance it. So the final piece in the puzzle, once we're in production, is some very, very robust finance options, so that you can get the monthly payments for one of these machines down to what it would cost to own a posh car. So that's our target for affordability. So it's less important to obsess about the ticket price, because that's not what drives the decision to buy a helicopter. It's always been running them that's the bigger concern, not buying them. So control the depreciation and then keep the operating costs under control and make it financeable. If you do that, we'll be back to the heydays of the 60s and 70s in terms of what general aviation can be.
Very good. And Robin is asking, why can't we adjust the cyclic? Shouldn't we be able to do that with this type of design? The length of the cyclic.
It's much more complicated in practice than you think it is. And we've looked at everything that everybody else has ever done, and everything we can think of to do, and we still think that pegging the cyclic in the floor and then moving the other bits around it. The seat's an easy one to adjust, and the seat actually works, doesn't it? If you're a big person, moving the seat back helps with the CG, the longitudinal CG of the helicopter. And if you're a small, light person, moving the seat forward helps with that. So it's a very natural thing to do for the aircraft. The pedals is just a real inconvenience as to how complicated they are when you've got wheels and you need toe brakes. But the way we're doing it, in my opinion, is definitely the most practical way that you can do it. So I think the cyclic has to stay where it is.
Very clear. The next question, which is number 39, I'll answer that one, and I'll give number 40 to you, Jason. So 39 is, what are the news on the flight simulator, either a Microsoft Simulator or X-Plane? Well, we do have news on that, and we're targeting Q2 next year. So stay tuned there. It'll be most probably announcing that before Q2, but that's our target date. Jim is asking, and actually has a comment before that, congratulations on incredible update. And then the question, I was wondering if you are doing more of a top-down waterfall project management or agile methodologies. What seems to work best for your product development process?
So again, this comes down to the dynamics of big team versus small team. You know, here at PC1, I sit in a little glass box in the corner of the development office where I can see every single one of my staff, and we found that the process that works best is quite simply just working through a very high level plan with a very detailed day-to-day and week-to-week jobs list of outstanding issues that we've got to resolve. I control the top level plan, and then each individual engineer works with a week's worth of time horizon. So they don't necessarily have to worry about the bigger picture. They just have to focus on what needs to be done in the short term. So we're able to create short-term urgency and short-term deadlines to make sure that we keep moving through the project as fast as we can. It's not sophisticated, it's not clever, but it works really effectively. And then we do the same throughout the business.
And Dave is saying thanks a lot. He says his wife, also a pilot, has scoliosis. She's fine flying Robbies, so I think it'll be fine. Just wanted to see how much extra cushioning or padding she would be using.
Again, we'd review that on a case-by-case basis. So the seats are more comfortable than anything that I've sat in an existing helicopter, so she should be better off. They conform to existing and accepted best practice for seating design. So I'd be surprised if there were any specific problems. But if she needs additional cushioning, then just call and we'll do what we can.
Okay.
Another question from Gene. Will you be designing a user-friendly tow unit for the skid unit?
I haven't thought about it yet, to be quite honest. But yeah, any options that the customers need, if there's a demand for it, then yes, we'll do it. I was talking with our undercarriage specialist today and looking at what the options are for ground handling wheels with the latest skid design. And we're evaluating a bunch of things at the moment to make it as easy to handle on the ground as we possibly can. So I expect we'll end up looking at a tow cart. My preference would be to have a version of the over-center wheels that have the HeliMove motors in, so that we can use the same HeliMove interface, prop it up on some little casters on the front of the skids, and then use the driven wheels on the over-center wheels at the back to drive it into the hangar. I think that's probably where I'd like to get to, but we've done nothing on that yet.
Good, and we've got a few more questions to go here. We've got about 5 minutes before we're going to be closing the session. It's been a really good session here today. And Peter's asking, how will the maintenance be organized over in Europe, such as the Netherlands?
So it's the same as everywhere else in the world. So we want to support all of the great helicopter businesses out there that have been supporting the existing fleet of helicopters. So as Ruben said, around 6 months before production starts, we'll be inviting formal applications for service centres, and then each helicopter that's sold is sold with a maintenance course. So your preferred maintenance technician can come to the factory and be trained and approved as to how to look after the HX50, and that can be added to their local approval. So it'll be done locally to you. In terms of the support of sort of component overhaul or component repair, all of that will be covered under the warranty to start with, and then as we go further into service, there'll be a power by the hour maintenance scheme which covers all of your parts to keep that as simple as possible. So major modules like the engine, servos, gearboxes, things like that, we'd likely do a module swap on things like those for any issues that cropped up in the field on early units, just so that we can see it for ourselves in case there's things that we need to learn from that. So we'll make it very, very simple from a customer standpoint. And of course, because we make everything, the cost to me to do that is as low as it can possibly be. So we can carry some stock, we can carry inventory of parts so that nobody's kept on the ground any longer than they need to be.
Fantastic. Next two questions, I'll answer those really quickly, and then I'll give you the other one, which is number 47. So VAT, any other taxes for exporting from the UK to the US? No, there's no VAT applicable to any export. VAT is only applicable to UK deliveries. And the other one is, do you plan to be at AHI Verticon in Dallas? As Jason said, we're extremely focused on delivering what has been public, and the dates are tight but possible. So all the team, the entire team, is focused on that objective. So no, we're not going to be at the HI Verticon, and we do have an incredible showroom that has been prepared to receive anybody that wants to visit the factory. PC1 has been a lot of visits lately, and that'll continue. You can enroll and come and see the helicopters yourself. So you're welcome to see the facility, everything being just working and having the team there for you to ask questions. But we're not going to be going anywhere. We will focus on delivering the helicopter. Next one. Can you fly an IFR approach in VMC with the HX50? In the R66, we use the GTN 750 to do this and fly it with the Garmin Pilot approach.
So no, at present, the DigiCockpit is VFR only. As we move further through development, we'll be developing an IFR capable version, and then subsequent products will obviously be IFR. So it is coming. It is not currently possible on the DigiCockpit. We haven't developed that in yet.
Okay. All right, and a couple quick questions I'm going to just answer very quickly because we're running out of time, and then we'll go to another one for you, Jason. So can we fly with the doors off? Yes. Will there be float provisions for the helicopter? Yes, we're going to have emergency floats for the helicopter. And then Peter's asking, when will the 4-axis autopilot be available?
Right from the start, right from the get-go. We're all over that at the moment. I really wanted to do a big section tonight on the 2 and the 4-axis autopilot, because there's all sorts of great stuff to report on that. But as I said, I think it will be better served when we've got the new stick heads ready, and when you can see some of the servo details and things like that. It will be much easier to explain once we've got that in hand. So I'll pick that up later, but you'll love it. You'll love what we've done.
All right, Ferdinando is one of our clients in Italy, and this question could be applicable to any country. When do you think will be delivered and certified in Italy? Can you talk about the different rollouts of certification and permit to flies in countries?
Yeah, so again, is this for X or for C?
I think it's X, yes. Ferdinando is a client for X, yes.
Yeah, so for X, the UK approval will be done as early as possible in 26, as I said, and at that point we'll prioritise the countries in terms of where the machines are going first, and then we'll systematically work our way around the countries to get the approvals done as fast as possible. Again, being a machine that fully conforms to Part 27, developed under a DOA, built under a POA, it makes the whole process a lot easier because we're a credible organisation. So our certification team will work through that as soon as is humanly possible, but we have to focus on the UK approval first, because that sets the precedent for the rest of them.
Okay, wonderful. And I'm just going to ask the last question here. We've run out of time. It's been an incredible session. I want to thank everybody for taking their time to be here, to enjoy having question time together with Jason. Jason, I want to thank you for taking the time out of your incredibly busy schedule to be able to answer everybody's questions and keep everybody up to date on what's been going on. So I thank you for that. And it's been another great session. The next session, actually, we're going to have another AMA, and it's going to be coming up on February 13th. So stay tuned for that. You'll be receiving a link some days before with the ability to log in for that session and any future sessions as well. So we're going to finish it off with fuel. There's 2 questions on fuel. The first one is about the forward fuel tank. So will the forward fuel tank always be mostly fueled, and can it be flown with it empty? And then following up on that, where is the fuel port location? So where will you be refueling it?
Yeah, so in terms of the forward fuel tank, you have no control over that. The system manages that to put the fuel CG in the right position relative to the rotor mast. So we've dealt with that question before. The packaging of HX50, to get a fuel tank that's this big, the main fuel tank is actually too far back. So the trim tank is just there to artificially bring the effective center of mass of the fuel to the position where we need it to balance the aircraft. And then the fuel control system manages all of that. So you'll never have any control over the level of fuel in there unless it's a fault situation, and then you can manually isolate it and manage the fuel level via jettison or isolation yourself. So that answers that. And then the fuel filler cap is actually behind the blackout panel on the side of the fuselage. So there's a little opening panel there where you can get to the fuel filler.
Okay. Wonderful. Why don't you sign us off, Jason?
Yes, well, thank you very much for your time and attention, guys. Thank you for all the questions as always. I hope you've enjoyed the update. We'll keep the mini updates coming out over the Hill app, and then we'll speak to you all again properly on the 13th of December. Thanks for your support throughout the whole of the year. Have a great Christmas and New Year, and we'll see you in the new year.